Hey guys, how's it going? Purple Wave Chemistry, Coach Scott here. So let's talk about doing a review of stoichiometry, otherwise known as BCA tables, or BCA tables, otherwise known as stoichiometry for AP Chemistry. Okay, I haven't forgotten you guys. So let's look over here and let's look at what stoichiometry is. Stoichiometry is it's a Greek word, means how much. All right, so what we're going to do, if you recall from our study on BCA tables, is some rules, and we want to keep those rules. Now, there's another way of doing stoichiometry, and you can see lots of videos on how to use dimensional analysis, and that works for them, and that's fine. I think this is much easier, and it helps you understand ratios. But let's take something, aluminum oxide, formed from aluminum and oxygen. Alright, so first you've got to have a balanced reaction. So this is a combination reaction. Alright, Al2O3, and I'm assuming you know how to do all this, and I know you do. So anyway, let's see, I got two aluminums there, so I need two there. I got two, I'm going to jump too much on aluminum. Let's look right here. I'm going to need two of these. Let's put some black. Two for 6 oxygens, and then aluminum oxide. So that means I'm going to need 4 aluminum. So now I've got a balanced reaction. Cool. I'm ready to go. Let's set up a BCA table. Then we'll throw some questions and remember how we use a BCA table. Remember before, change, and after. That's what we're looking at. I'll do all 3 of these there for all of them. Alright, B, C, and A. So let's say, okay, this is how we use our BCA table. Another rule of BCA table, anything in the table has got to be in moles. If they're giving you grams, if they're giving you liters of a gas, you've got to be able to convert that into moles. Everything in the BCA table is only in moles. So let's say we've got 15 grams of aluminum oxide. I'll write that down. 15 grams of aluminum oxide. So how many grams of oxygen? Oh, don't have the right stuff there. How many grams of oxygen are required to produce 15 grams of aluminum oxide? Okay, I'm looking at the left-hand side of the table right there. All right, so first I've got to get the number of moles. All right, so I've got to find molar mass. Y'all know how to do that. Okay, so if I look on my periodic table here, 2 aluminums, that's 2 times 26.9815. 0.9815 plus I've got 3 oxygens, that's 15.99, 3.999. So that means it has a molar mass of 101.96. Alright, so that means for every 1 mole of aluminum oxide, I have 101.96 grams. Okay, so for every 1 mole, I've got 101.96 grams. I've got 15 grams, so for every, let's see, so I'm going to do 15 divided by 101.96. So that means I've got 0.147 moles of aluminum oxide. So, of course, we don't have any moles to start with, but I'm going to make 0.147. 0.147. Now here's where the beauty of the BCA table comes through and the reasoning behind it. So if I look for my oxygen, so every 2 moles of aluminum oxide, I'm going to need 3 moles of oxygen, O2. Alright, so So for every 3 moles of oxygen, I'm going to need 2 moles of aluminum oxide. So I can do it over here. So for every 3 moles oxygen, I need 2 moles. So for every, yeah, you got it, Al2O3. So I've got 0.147 moles of oxygen. So how many moles of, so that's going to be, what, 3/2? So for one, it's going to be bigger. So what ratio makes this number bigger? What's 3/2? So I'm going to divide by 3/2, or multiply by 3/2. I got 0.22 moles of oxygen. And let's just use reasoning. And 0.221. All right. So this number has to be bigger than this number, right? Because this has 3 moles, that has 2 moles. So what ratio makes this number bigger? Well, 3/2. 2/3 makes it smaller. Let's go ahead and do the aluminum. So this has got to be bigger than that, but how much? Well, 2 times, 4/2, or 2/1. So 0.147 times 2. So that means you got to have 0.294 moles of aluminum to even start. All right. So of course all that gets used up and everything's good. So I need 0.221. That was our original question. So let's go back to the black here. I need 0.221 moles, and it asks for grams. Moles O2. So now what I got to do, I've got my answer through my table in moles. I've got to convert it over into grams. So for 0.221 moles O2, 0.221 times the molar mass of oxygen, which is 15.99 times 2. That gives me 7.07 grams of oxygen. So think about what I did here, guys. I used the BCA table. All right. Anything that goes to the BCA table has to be in moles. They gave me the number of grams of aluminum oxide to finish with. I converted that into moles. I threw that in my table. After I got that number in my table, then I can use my mind reasoning with that balanced equation to get the answer. All right. I think this is easier. I'm going to show you the other way real quick. So if I got 15 grams of I still got my balanced reaction right there. All right. So I've got 15 grams. I don't know what I'm doing there. Let's do that. All right. There we go. Okay. So I got 15 grams. Whoops. Al2O3. This is called dimensional analysis. All right. So I got converted into moles. So we use little train tracks, and that's 101.96 grams. Al2O3 for 1 mole. So now I've got moles of Al2O3 and multiply by the mole ratio. Okay, so let's see. That's 2 moles Al2O3. So 3 moles O2. That was the question. And times, let's see. So that gives me moles of O2. So for every 1 mole of O2, it's got 31 grams. O2, that's the molar mass, and that's going to give me, if I do all that, let's do it on my calculator real quick. 15 And if you think about it, if you think about the math, I'm doing the same thing. I did 101.96 times 3 divided by 2 times 31. I get, well, close, 6.84. Yeah. So I get about the same thing, a little off. What works? You know, which one do you want to use? To my mind, there's more reasoning with this. You got to do almost the same methods, but once I got all this drawn out, I've got my balanced reaction. I can answer everything with it. So, guys, another way of doing stoichiometry. This is dimensional analysis. This is a BCA table. You guys know how to do stoichiometry. So go out and do great things, guys. This is Coach Scott, Purple Wave Chemistry, saying, Hullabaloo, connect, connect.